This is the example problem on slide 80 of our chapter 13 PowerPoint. In this example, we are using Le Chatelier's principle to predict the direction our equilibrium will shift if we add or take away components or change or disturb the equilibrium in other ways. So the question reads, methanol is used as a fuel additive. Describe the effect of each of the following changes on the equilibrium mixture for the combustion of methanol. We have the combustion of methanol written, and there are several different changes that it wants us to figure out how the equilibrium is going to shift. So basically your answer for this is going to be it either shifts towards the reactants or towards the products, and you can indicate that with an arrow. So Le Chatelier's principle basically states that an equilibrium is going to, if it's disturbed, it's going to shift in a direction to try and minimize that disturbance. So when we add things, the equilibrium typically shifts in the opposite direction. If we take things away, like reactants or products, it's going to shift in the same direction. So for increasing the concentration, adding more CO2. So CO2 is over here as a product. If we increase that concentration, my equilibrium is going to shift away from that change. Because basically we've added more CO2, the reaction wants to get rid of it, so we're going to shift more towards the reactants. So our reaction is going to shift left. For oxygen, oxygen is a reactant, and if we add more of it, this is for part B, if we add more O2, the reaction is going to want to shift away from that, so it's actually going to shift to the right towards the products. Now, volume can get a little more tricky. It's not as easy as just looking at the reactants and products. Here we actually have to count up the number of moles of gas on each side. And basically that's going to determine which way we shift. So to count up number of moles, it's just looking at how many total molecules or moles of each gas we have on each side. So on the first side we have 2 moles methanol, 3 moles of oxygen, for a total of 5 moles of gas. And on the other side, we have 2 moles of carbon dioxide, 4 moles of water, for a total of 6 moles. So for part C, it says, how's the equilibrium going to change when the volume of our container is increased? So when volume increases, that means our pressure is decreasing, and we want to shift to the side with more moles on it. So if we look and compare, on the reactant side we have 5 moles, and on the product side we have 6 moles. So therefore, as we want to shift to the side that has more moles, our reaction is going to shift towards the products. Now if that had been the opposite case, if reactants had more products, if reactants had had more moles than products, we would have shifted in the opposite direction. Now you might be wondering what happens if I decrease the volume of the container. When you decrease the volume, it's going to shift to the side with the least number of moles. So don't get those two confused when we're working problems in your homework. Part D says, what if we increase the temperature? So this also has a lot to do with whether our reaction is endothermic or exothermic. So remember, endothermic means you're absorbing heat. And so typically in equilibrium reactions, we would represent an endothermic reaction by writing the heat absorbed as a reactant. For exothermic reactions, we represent the release of energy, the release of heat, by putting the energy that is produced as a product. So if you look here, on the slide and on your slide in your PowerPoint, you'll notice that we also produce 1450 kilojoules of heat. So that means my reaction is exothermic. Now, we treat heat as any other product. So if you add more to it, if you add more heat, which means an increase in temperature. So increased temperature means adding heat. Decrease in temperature means taking heat away. If we increase that, we can think of it as any other component in our reaction mixture. If you increase something, it's going to want to shift in the opposite direction. So therefore, my reaction would shift left towards the reactants. And then finally, what's going to happen if we add a catalyst? Now, catalyst, the main thing that you need to remember about catalysts is that they may speed up a reaction, help you get to equilibrium faster, but they have no change whatsoever on shifting the equilibrium. So if you add a catalyst and your reaction's already at equilibrium, it's not going to do anything. So adding catalyst means there's no change. There's no shift in which direction the equilibrium will go, either towards products or reactants. Absolutely no change. And there you have it. That is several different examples of how changing states about the equilibrium shifts it towards reactants or products.